Okay. So thing is that so when I take r equal to 3 in this particular problem, so when I take r is equal to 3, then my h becomes, right, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. Like that, I'm taking all non-zero vectors. So this is related to 1, this is 2, decimal representation, this is 3, and this is 4, right? And 5, 6, 7, right? So this is my parity check matrix. Try to understand. Now the size of this matrix is 3 by 7. So my size of G equal to 4 by 7, right? This is generating matrix. You know that the minimum distance of the code is equal to the minimum number of linearly dependent columns, right? Here we know that any two columns are linearly independent, but three columns are linearly dependent because that the distance of the code is 3. So now the parameters are so 7, comma 4, comma 3, right? And further we are to understand that it is a perfect code. Why it is a perfect code? Because the distance of the code is 3. That means that if I take a circle of radius 1, right? So then these are the code word, and how many vectors will be there inside that, right? So this is exactly 1 plus um, n choose 1, right? Multiplied by number of code words, right? So each code word contain that many code words, vectors. So I'll multiply with the 2 power k, right? So 2 power k into this, but n equal to 2 power k minus 1, right? So it is equal to how much? That is the question, right? So this is equal to 2 power k into, so 1 plus, this is 2 power, this is 1 minute. See, when r equal to r is given, my n is equal to 2 power r minus 1. My k is equal to, so you know in h size is r cross n. Okay. Now g size is going to be n minus r cross n, right? But what is k? K equal to n minus r. Okay. So this is 2 power r minus 1, right? So because of that, what happens? 2 power r minus 1 into 1 plus 2 power r minus 1, choose 1, right? Okay. Um, yeah, so this many vectors, right? So it is 2 power this much. This is 2 power, right? So which is equal to what? So which is, you will see that it is exactly what is that we will get. Do you want me to write clearly? Are you following, or is there any problems?
I think it's 2 power r minus 1.
Yeah. So see here. Okay, I'll write it clearly. This is 2 power r minus 1 into 1 plus 2 power r minus 1, right? So now you see that this 1 1 gets cancelled, this r gets cancelled. So it will get 2 power r minus 1, 2 power, 2 power r minus 1, right? This is equal to 2 power r minus 1. So it is equal to 2 power n, right? So that is the perfect code means. So I'm able to cover all the vectors in F2. Okay. So this can be extended to not only binary, in general, you can extend it to any code also. So that's what I want to say. This is called Hamming code. This is very best code, means with the distance, these are the best parameters. Yeah. So the dual of this code is called simplex code. Better find out the parameters of that. Okay. Now this code is obtained from the first code by what? You recall the problem one. Anyone fast? Sorry for delay.
Adding 1 to the first row and zeros to the first column.
So see 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. So this is actually a linear matrix only, but I'm adding one extra column here and here few zeros, right? So now what is the size of this matrix? So earlier, the size is R cross R I took once. So this is R cross N, right? R cross N, but N equal to now how much? Look at N is how much? Columns you can easily tell now. Earlier number of columns are this much only, right? Now one extra column also added. So can you tell me what is N equal to now?
8.
In this case 8, but that is R equal to 3 case. In general, what is the N?
2 power R.
2 power R, okay. Earlier 2 power R minus 1. Now I've added 0 column also here, right? If you look at this, only these last three columns, last three rows, okay. And it is 2 power R. And what is the size of this matrix now? This R plus 1, right? R plus 1 cross N, right? R is equal to 3, then it is 4. So so parameters are now for this matrix. Now this is 2 power R, comma what's the parameters of the code? Try to understand. This is the code for this is the parity check matrix, not the generating matrix, right? So can you tell me the parameters of the code now? N comma k value, can you tell? This is n minus k, right?
N minus R minus 1.
Yeah. So it is 2 power R minus R minus 1. Yeah. And what is the distance now? Yeah. So try to figure out that. So again, you will see that it is self-dual or not. That also you need to figure out that. So it is, yeah. These are the some of the questions here. Yeah. So now I hope from here onwards you will follow, every one of you. So it is a binary repetition code. Find the parity check matrix for C. Can somebody tell me what is the parity check matrix for C? What is generating matrix? Yeah. Now we'll go a little fast and yeah. What is generating matrix for this code? Okay. So tell me what is n equal to here?
3.
N equal to 3, right? Right. What is the k value?
2.
Mehak? Okay. C is subset of what? Suresh, go ahead.
C is subset of F to 3.
F2, 3, correct?
Yes.
So F2, 3. So it is a linear code, right? Is C linear? I'm asking just a little fast. This you know already. You see a linear code? Suresh, go ahead.
Yes, sir.
It is a linear code, right?
Yes, sir.
Yeah. Why it is a linear code? Because linear code means actually in F2 pay, just it is a group with respect to addition, right? If you add any two vectors, again it is there or not, yes, right? So
Yes,
it is
sir.
linear code. What is the dimension of the code? That is this k value, right? How many linear independent vectors are there here? Only one. Yeah. So k equal to 1, n equal to 3, correct? So what is the now G matrix now? Can you tell me?
1 cross 3.
1 cross
3.
1 cross 3. Yeah. Can you tell me what is that? Only one row. What is that? Yeah, Mehak. No, no. See, very simple question. This is a linear code. It is called binary repetition code, right? It is subset of f to power 3. No problems, right? And why it is dimension 1? Because dimension means number of linear independent vectors in this, right? Only one is there. So k equal to 1. What is generator matrix for this? Generator matrix is formed by some linearly independent rows, right? We'll fix some k linearly independent rows, right? What is generating matrix for this? Mehak. Okay, so this is the matrix, right? No, I don't know. Again, there is a problem coming. So this is G. Now, what is a parity check matrix? What is size at least? What is the size of the parity check matrix?
2 cross 3.
One, one.
Hello?
Yes, sir.
Sorry, today a lot of problems are coming. I'm extremely sorry. Yeah, okay. So this is a parity check. This is a parity check matrix. This is a generative matrix for which code?
Which question, sir?
Okay. So see, H is this matrix, right?
Yes, sir.
H is a parity check matrix for this code. So
Yes, sir.
this is generative matrix for which code?
C per
CPerf. Okay. I think you are responding. I'm not audible to you. That's why problems came. Okay. So it is a generative matrix for CPerf. So, so can you write into generative matrix type means first identity like that, right? This is 1 0 0 1 1 1, right? I am interchanged these columns. So these two are same, right? So this is equivalent code, but so this is which code it is, what it is doing. Do you know this code also? CPerf also you know what are all code words, right?
Yes, sir.
Yeah, it is a parity check code, means actually, so all are even, right? Okay. Um, so now can you see that, you know, what are the cosets for this? Now, these are all okay. So we done that parity check matrix code. What are the cosets?
C itself will be one of the cosets.
Yeah, so I'll write that 0 0 0 1 1 1, right? This is one coset. Now, what is the next coset leader we take?
0 0 1
Yeah,
or
so
1 0 0
1 0 0. Yeah. So 1 0 0. Now, what is the element here?
0 1 1
0 1 1. Yeah. Next coset leader
0 1 0
0 1 0. Oh, here
1 0 1
1 0 1. Yeah. So next coset leader 1 0
0
0 1 0. Right.
0 0 1
0 0 1. And here I'll get
1
1
1 0.
0. Right. 1 1 0. 1 1 0. Yeah. Now all of them are adjusted. Yes. Total 8. 8 all are came here. Right. All of them are came here. Yeah. So now now these are coset leaders. Coset leaders are this part, right? And these are the all cosets. So there are total 4 cosets are there. So because it is a subspace of dimension 2, because of that, right? Yeah, correct. Okay. So for example, you receive the word 110. Then how do you get the syndrome? Find the syndrome. This will answer this question. So this we done. Cosets and coset leaders. These are the coset leaders. Suppose you receive a message 110, sorry, syndromes. Find the syndrome for each coset. Yeah. How do you get it? Syndrome for each coset?
Look at the code word that it corresponds to.
Coset lead syndrome
Sir,
syndromes for each coset is actually it is sufficient to look at the
leader.
reader, right? So what is the for example what is my h here? For that we need to compute h. H is equal to 1 1, right? 1 0 0 1, right? Now you take the first coset leader. So 0 0 0 if I take, so you know that I'll get again, right? So 0 0 I get. So there is no problem. So syndrome for this syndrome table is like this. So coset leaders, these are coset leaders. Coset leaders are these, right? These are the coset leaders. And here I write the syndrome, right? Syndrome means what? H into this R transpose. Okay, this E transpose. Coset leader I am calling E, let us say. Then E transpose, right? So here I'll get 0 0, correct? I'm writing in the column wise, so that row wise, so that it is easy. Yeah, syndrome is 0 0. What is the syndrome for 1 0 0? So multiply 1 0 0 here. Yes,
1 1
1 1, right? What is syndrome for 0, 1, 0?
1, 0.
1, 0. What is syndrome for 0, 0, 1?
1, 0, 1.
0. So you're getting all the vectors, all the syndromes are distinct. Yes, that is one more problem. Explore later. Why all of them are distinct? Okay, yeah, fine. So now these are the syndromes. So this part is done. Now suppose you receive a message 110. Then how to decode it, right? So no decoding method. 110. 110 is in which row? In the last row. So now what is that I have to do? Right? I had to add this to get the my code word, right? 110, either add or subtract, both are same, right? So I'll get one here, one here, one here. So this is now decoded to 111. Yeah. So this is done. Is it clear?
No, sir.
Not clear.
I mean, I understand why it should be 111, but where did we use syndrome here?
No, we are not using syndrome here in this particular case. We are already directly using that. So syndrome where we used, okay. So the syndrome of 110 also same thing, right?
Oh, okay, okay. Understood. Okay, so if we multiply h by 110, then we get 01, which is corresponding to 001. That's the logic, right?
That's the logic, yes. So we already computed syndrome table, right? So this is very small table, right? Generally, this is very big row. Code dimension of code is very large, right? Then so you compute the syndrome and corresponding to which code it is, and we'll take it directly. Yeah? So we no need to look at the. This is called standard array. We cannot, no need to compute standard array. That is very complicated, right?
Yes, sir.
Thanks. Yeah, thanks. So, but other people, so is it all of you are clear? What is that we are doing? This 110 also, what is that he asking is that, see, 110, so, but since table is available here, I no need of all these things, syndrome, okay? Directly in the table, so the quotient leader is 011, I am subtracting, but it is in general very difficult to construct a table. Okay, directly will compute by syndrome. So that is what the Amiya's question. I'll explain you. So H into this 110, find the syndrome again for this. This is center, right? So this is equal to what? Okay, so this into this, so we'll get 0 here. Yeah, so 0, 1. So that is corresponding to this quotient leader 0, 1. So that way, table is not. Yeah. Now is C is an MDS code. MDS code means what? So where D is equal to n minus k plus 1. Is it true? What is the distance of this code?
3.
3. Okay, D equal to 3. N equal to k equal to Is D equal to n minus k plus 1? Yes, right. So it is a MDS code. Find the Hamming bound. Hamming bound means what? Okay, so for example, if I take what are the code words in this code? Very simple problem. What are the code words in this case?
0, 0, 0 and 1, 1, 1.
Yeah, so 0, 0, 0 and 1, 1, 1, right? So I have two circles only, right? So now, what is the radius of this circle I take generally? My
1.
distance is 1, right? So I'll take one distance 1, right? Now, which vectors will be there inside this ball, including radius 1, right? This first ball contains 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, right? Second ball contains 1, 1, 1, 0, 1, 1, 1, 0, 1, right? And 1, 1, 0, correct? So is it all of them are packed here in these two circles?
Yes, sir.
Yeah, so it is a perfect code
Perfect
also.
code.
This is perfect code, this is MDS code. Yeah, so all of them are there. Yeah, so please check all these things one more time, this simple example. So any questions before going further?
Is there any relation between MDS code and perfect code?
No, no, it is they are different. See, MDS code is what? MDS code. So MDS code even yeah, MDS code which is that bound, which bound. So for example, distance is d, right? If the distance is d, uh, there are n places here, right? So distance is d. Okay, then I'll remove d minus one positions. First d minus one positions, right? Then how many? What is the length now becomes? It is n minus d plus one length, right? Are you following?
Yes, sir.
So now what is the maximum number of things we'll have here? How many words can be formed? Words only, code, not code words. How many words can be formed of length n minus d my plus 1 over fq?
Q power n minus d plus 1.
Q power n minus d plus 1, right? But whereas, um, so if after removing uh, these are code words, right? Some code C and with cardinality M, right? Now, if I remove the only first d minus 1 positions, okay, there is no change in M. I'm listing all the code words. I listed all the code words. There are M are there. In that, I removed the first d minus 1 elements. Still, are they distinct?
Not no, sir. They may not be distinct.
No, they are distinct. So this we done in several ways, but giving one proof now. So what is that I want to say? See,
Can you repeat the question?
yeah, I'll repeat that. See, for example, my code is NMD code. Okay, it is even need not linear also. NMD code. In NMD code, right? So I have these are n positions, right? So n code word one. So this is code word one, code word two, code word three, like that. Code word M. So how many are there? M are there, right? Now distance is d. So now I take the first d minus one positions, right? I removed them. Okay. Now how many words still left now? I'm not removed any word at all, right? Only remove the first positions only. Still how many vectors are there? M are there, right?
Yes.
But now the question is that is there any two words here that are they equal?
No, sir.
No. If they're equal, what happens?
Then the distance of those two becomes d minus 1.
Yeah. So then becomes d minus one, but distance is d, right? So because of that, it is not possible. These are all distinct. Okay. So these are all distinct. So then, so so because that now m is less than or equal to what?
Q power n minus d plus 1.
So maximum I can have this, right? This is a very big upper bound, but m cannot be greater than or equal to this. I can say this m value, I can say like this. Right? This can be proved in various ways. We proved in another way. You take the generating matrix, right? Then with that also we done. You remember that? And by using parity check matrix also we can find out. Okay. Anyhow, MDS code various properties are there. Okay. Right. Okay, this is another question, question number 5. C is a binary code with like this. Is C is not linear. Why it is not linear?
Sum of second and third vector is not in the.
That is one thing. Is there any other way, Suresh?
Yes, sir. Distance is not equal to weight. Also, zero vector is not there.
Vector is not there. Okay, very many ways you told. Very nice. So question is that what is DC? But it is a code as such, but it's not a linear code. What is a linear code which contains C? Is the question clear? I'm not explaining, I'm just telling the problem. Is C not linear is clear to you? Now the question is that what is a linear code which contains C?
I think the span of C.
Span of C, right? Yeah, correct. Wonderful. So that you need to figure out. You understand that.
Sir, but
Hmm.
it may not be unique, right? Because span will be the smallest linear code that contains C.
Yeah. So
Anything bigger than that will also.
no. Yeah. So I'm okay. Smallest. If I do not ask, then there are. It is not unique. Even you have entire f2 power whatever is also there, right?
Yes, sir.
Yes. Okay. Yeah. So that C. Okay. Singleton bound. Okay. Okay. Fine. We'll go to the next question. So it's question number 6. So I'll involve now every one of you. Okay. So concentrate. So, you know that NMD code say I'll get n plus 1 and n plus 1 d md plus 1 code, right? You know how to get it? Parity check matrix, right? Overall parity will add. You remember that?
Yes, sir.
Yeah. So that way we'll always get and distance also increased by 1. Yeah, this is the question about that. Is it okay? So for example, you take 0, 0, 0, 1, 1, 0, 1, 1. So I'll add parity check to this, right? Now it is now here it is the parameters are n comma 4 comma, right? So sorry, 2 comma 4 comma 2 comma 4 comma 1, but here it is 3 comma 4 comma 2, right? I hope it is clear. So this can be done always. Yeah. Now look at this code, which is equivalent to this code. Okay. So how do you do that? We want to show that it's equivalent to this. See, I'm giving interchange 0 and 1 and interchange the positions of 2 and 4. Is it clear? Okay. So how do you get actually equivalent code, right? You change the symbols and you also interchange the columns. Like that you can get the equivalent codes. Okay, I'll explain further. Okay, I'll give one example here. Let's see where linear code with generating matrix is this, right? Okay, then so find the code equivalent to this code where generator matrix is in systematic form. It is now, it is not in systematic form, right? I want to bring it to systematic form, right? So rearranging the columns in the order 1, 3, 4, 2, 5, 6, 7. Okay. So C dash be the code obtained from G dash. Then C dash is equivalent to C and C dash is generating matrix for G dash, which is in the standard form now. Right? Okay, this is the better way to understand question number 10. So we can answer 9 also with that. Two K-class and matrices generate equivalent codes over FQ. One mat is obtained from the other by sequence of the operations in the following type: permutation of rows, multiplication of row by a non-zero scalar, addition of a scalar multiple of to another row, and permutation of columns, and multiplication of any column by a non-zero scalar. So these two earlier we discussed. It is true for any code C1 and C2. Permutation of the columns and multiplication of any column by a non-zero scalar. This is in general true for any code, not only linear. In the linear, we have extra three conditions. Why? Linear code, how do you get linear code actually? Linear code complete linear code comes from where? Linear code can be constructed once you know something. What is that?
Basis.
Basis. But basis can be formed into generating matrix, right?
Yes, sir.
Yeah. So, you know basis, then their linear combination is only the entire linear code, correct? Now, this is my first row, one vector, basis, first vector, second basis vector, third basis vector, let us say 3 by something, right? Then if I interchange two rows, what happens is the code will change, linear code, no, right? Basis vectors, first basis vector, second basis vector is not a problem. Are you following?
Yes, sir.
Yeah. So the permutation of rows not a problem. This is allowed. Multiplication of a row by non-zero scalar still, because it is a linear code. That is also a code. So I am replacing this vector with another vector. Still they are linearly independent. So not a problem, right? This also I can do, right? Third one also same thing. They are again linear combinations. So they are again the elements in the linear code only, right? Permutation of column. This is earlier we done. How to say two codes are equivalent? These are the two operations. Okay, interchange two columns or rotate inside that one. Okay, so these are the things. Okay, so I'll explain it one example so that it will be clear. Look at this code. So are you able to see that? So this original code I converted into this code. You see that operations what we done. Only here I done only row operations. You see that?
Yes, sir.
Yeah. So like that we can convert. So question here is that let's see a linear code over F3 with generator matrix is this. List all code words in C. Yeah. Can you do it fast? How do you do? Mehak, can you tell me how do you get all the code words in C?
So G is the generator matrix, right?
Right, right.
But
What?
it should be in the form of identity and A.
No, that is need not be like that. That if it is there, that's why find a systematic generator matrix for C also. Generator matrix need not be of that form. See, generator matrix only found with independent rows.
Okay, sir.
See, so for example, this is a generating matrix. Okay, for example, is it a linear code? And again, one more time explaining. So 0, 0, 0, 0, 1, 1, 1, 0, 0, sorry, 1, 1, 0, and 1, 0, 1. Is it a linear code?
Yes, sir.
So it is a linear code. So it is subset of what? F2 power 3. Yeah. So n equal to how much?
3.
N equal to 3. What is the cardinality of C? This is my C.
2. That is 4. 2 raised to 2, which is 4.
2 raised to, so K equal to 2, right? K equal to 2. So that means my G matrix is 2 by 3, correct?
Yes, sir.
Now what is that I have to take here? Okay, I cannot take 0, 0, 0. Why? That is not linearly independent vector. So which vector I can take here? First vector.
101.
Yeah, 101 I can take, 110 I can take, 011 I can take, right?
Mm.
I'm allowed to take anything. So I will take 011 this time, okay? To clarify your doubt. But second vector I can take any other vector, right? So these two are linearly independent, these two are, so I can take any other vector, right? 110 I take, right? So this is also generating matrix, but now it is not on the form, systematic form, okay? But I can interchange it, I do row operations and I'll bring it later. Are you following? It is also generating matrix. Can you give me another generating matrix for this code?
101 and 110.
110, right? Right. Another generating matrix. So you take any two columns, any two vectors here, that forms a generating matrix. Is it now clear?
Yes, sir.
Yeah, good, nice. Okay, but so I already gave C. I already gave C, but this C comes from generating matrix. So I'm erasing C now. I'm erasing C and I'm only gave G to you. Then how do you get to code? Right? We studied that. Are you following what I'm saying? So my point is that I have G equal to 101 011, right? This is my G. How do we get C now? You know the answer. C you already know, but how do you get it actually? You know, G is a map from where to where. Remember those things. Okay, so that is the question. So if you understand this, now tell me answer to this problem fast. What is C in this problem? Yeah, Suresh.
Yes, sir. So total 9 vectors are there. Linear combination of these two rows. 2 1 2 1.
Very good. So size of this matrix is 2 by 4. Okay. So G is a matrix from where to where? It is a linear map from where to where? You are correct. Cardinality C is equal to 9. But what are those? I need to figure out this. Yeah.
F2 3 to F2 9.
F
So sorry. F3 4 to F9.
F3 only.
So 9.
No. 4.
Oh, sorry. Yeah.
C Q power K to FQ power N.
Yes, sir.
Okay. So okay, fine. So F3 2. What is this? What are the elements in F3 2? You know F3. F3 cross F3, right?
Yes, sir.
Hmm. Tell me the vectors 0 0
0 0 0
0 1.
1 0.
No, go slowly, systematically. See, F3 2 means F3 cross F3. Okay, what are the vectors? 0 0 0 1 0 2 1 0 1 1 1 2 2 0 2 1 2 2. Correct? So now, how do you get the C now? What is C now?
So add first row to 0. So in this you
Yeah,
consider this 0 0.
0 0 G, right?
Yes, sir.
Yeah, 0 0 G, what I am going to get, right? I'm multiplying this row by 0 and this row by 0 and adding them.
Yes,
What,
sir. So first one is 0 0 0. Then
what is 0 1 if you multiply get?
0, 1, second row, that is 1, 1, 1, 0.
Very good. Nice. 0, 2.
0, 2, then 0, sorry, 2, 2, 2, 0.
Very good. 1, 0.
First row, that is 2, 1, 2, 1.
Yeah. 1, 1.
Sum of these two rows, that is 0,
Mm-hmm.
2, 0, 1.
Very good. Wonderful. So I hope all of you are clear. Like that, we'll get. This is the way. Find all code words in C. Is it okay, Mahak, now?
Yes, sir.
So this is the matrix given. I want to find C. So this is 2 cross 4 matrix. Field is F3. So G is a map from F3 to F3 power 4. So I'll take all the vectors here and I'll multiply it to this G. Yeah. What is the minimum distance? Okay, can you now, okay, can you give me generative matrix? Now we have completed the entire code, right? Can you give me vectors so that first becomes identity here? Can you give me code word with 1 0 starting? Do you have here? अभी तक तो नहीं आया है. Hello? So let us write down. Yeah, so 1 2 if I multiply what I get? 1 2 I multiply to G what I get? Hello?
That is 2, 0.
No. So this is multiplied by 1 and we adding 2 multiplied by, this is multiplied by 2 and adding, right? 2 plus 2, 4. So 1, right?
Yes.
So
1 0 1 1.
1 0 1 1. Okay. Now I'm now going to 2 0. 2 0 means now. So multiplied first vector by multiplied by 0, 2 and second by 0 and adding them. It is just linear combinations. Okay. Yeah. Okay. Can you tell me now? So multiplied by 2. First one multiplied by 2. So 1,
1 2 1 2.
1 2 1 2. Okay. Now right. So 2 1. First one multiplied by 2. So that is we already done. Right. This is the what we got. Right. Adding to the second. What I'll get. This is multiplied by 2 and this is multiplied by 1 and adding. So already multiplied by 2 is here, already available here.
2 0 2 2.
2 0.
2 2.
Okay, good. What about the last one? 2 2. This also multiplied by 2 and adding to this, right? And that means actually this adding to this. Multiply this to 2 and add to this quantity.
0 1 0 2.
0 and 0 2. Now, do you have two linear independent vectors so that I'll get identity matrix now? This I can take. This I can take, right? Last one. Right? 1 0 1 1 and last one is 0 1 0 2, right? Is it in systematic form now?
Yes, sir.
See, now you multiply again these. Can you get the same code? Yes. You take any two rows is sufficient. Two independent things from here will work. Can I take these two? Is it from a generative matrix?
Yes, sir, they will form.
No, that will not form. Why? We need to take linearly independent vectors. In the previous problem, all are independent, that's why. But here, these two are not linearly independent. Why they are not linearly independent?
Because they are scalar multiple of each other.
So in the binary, it is all are independent. Once they are distinct, they are independent. But in the in other non-binary, there may be a possibility you need to check carefully. You cannot take these two, but you can take this one and this one. One from here, one from here, like that. Yeah. Okay. So are there any questions? Please ask now. Amaya, is it everything clear?
Yes, sir.
So you need to work out some example, then it will be clear. What is the minimum distance? Okay, you can compute again later. Okay, now look at this problem. In this problem, so we have a linear code NKD code over FQ, Hamming weight is given. W equal number of code words in C. So these are the weights. How many code words are there with weights? Okay. So W0 equal to 1, right? Why W0 equal to 1? Wi is number of code words of Hamming weight I. Why W0 equal to 1?
Only the zero vector has weight 0.
So what is Wn weight? We don't know whether it is there in the code or right. Yeah. Why Wi is equal to 0 for 1 less than or equal to I less than D? Suresh? Sonali? Okay, Rutuja, can you tell me why there are no words of weight 1, weight 2 up to weight D minus 1? Okay, Mehak? Not clear? Yeah, Amir?
Because the minimum distance is D.
Hmm.
So minimum weight is the distance of the code. So if the weight is less than D, then there will be no vector with that weight. So it has to be 0.
Yeah. Is it okay, Suresh? I think you also want to say something. Right?
Yes, sir. Yes,
Yeah.
sir.
See, minimum weight is D means out of all the non-zero vectors, minimum weight is D. D is the minimum weight of all non-zero code words, right? So that is itself is D means if anything less than that, we cannot find any code word. If there is a code word of minimum less than D, then minimum distance cannot be D, right? Yeah. Yeah. So now this is called generating function or something called a code enumerator polynomial. Yeah. Code word enumerator. Yeah. So for example, I'll explain you here, right? So what are the weights now? Weight 0, how many are there? Only one. Weight 1, how many are there? This is a number.
N.
Weight 1, weight 1.
N.
No, in this particular problem,
So in this one, 0.
0, right? Weight 2, how many are there?
2.
2.
3. Sorry, 3.
3. Weight 3, how many are there?
0.
0. So weight enumerator polynomial means we are taking W0 x power 0, right? Z power 0, right? And W1 x power 1 plus W2 x power 2 and W3 x power 3, right? So now this is 1 plus here also 0, right? So 3x square. So that is what. Is it clear? Example maybe weight enumerator polynomial. Is it okay? Yeah. Okay. Good. So can you tell me that what is the weight enumerator of this? 0, 0, 0, 8 times, right? Okay, I write like this 0, 0, 0 and 1, 1, 1. Okay, it is contained in f to power 8. Yeah. Can you tell me what is the weight enumerator polynomial for this? Yeah, Amir, go ahead.
1 plus z power 8.
1 plus z power 8. Now, you know C per? Yeah, for this, can you tell me what is generator polynomial? Or that weight enumerator polynomial for this? Is the question clear at least?
Yes, sir.
Yeah. Suresh, is the question clear?
Yes, sir.
Yeah. So I want to find, for example, what is the C perp for this? This is a linear code, right? What is C perp for this? What is the dimension of this code? See, you need to work actually.
2.
It is 2. So, and n equal to 3, k equal to 2. So, what is the C perp dimension? What is C perp
1.
dimension? 1.
1.
C perp dimension is 1. But we know C perp is a linear code, right? So, it contains one zero vector and one non-zero vector.
1,
But
1, 1.
But why it is 1, 1, 1 only? Why can't it some other?
That we can just, if we multiply it with the any of the non-zero vectors in C, then we won't get 0.
So see, so here 1, 1, 1 because 1, 1, 1 means actually adding the things, right? Multiplying by 1, 1, 1 means adding the vectors. So if I multiply with dot product with 0, 0, 0, 1, 1, 1, I'll get 0 because they are all even weights. We discussed this in the previous class. So a vector weight, code word weight is even is same as it is orthogonal to all ones vector, right? So these are all even weights. So it is everyone is perpendicular to all ones vector, right? Now what is the so for this one this one is 1 plus z cube, right? Yeah. So like that I'm asking here. I'm asking in general. See, here I gave this and C perp I gave here. Now I gave C. Now I am C perp is the other one. Am I clear?
Yes, sir.
Okay, I'll ask few questions so that it becomes easy for you. Okay. So let us take a small example so that it may be easy for you. Then you will tell for this. Okay.
Okay, so
Yeah. Tell me.
in C perp, we cannot have odd weight code words.
Yeah. So is it all of you are clear, Suresh?
No, sir.
He's telling. See. Okay. So see. This is my C. For example, this is my C and this C perp. He's saying that C perp does not contain a vector with odd length. So, for example, he's telling that I cannot have this vector here, C perp. Why? Because every vector here is orthogonal to every vector here, right? So it is orthogonal to this means this length should be, weight should be even. Are you following?
Yes, sir.
So what is that we are saying? So it is in the C perp, every vector is orthogonal to 1, 1, 1, 1, right? 0, 0, nothing. 0, 0, every vector is orthogonal. But a vector is orthogonal to all 1 means sum equal to even. So you cannot have words of odd length. So then what is W1, W3, W5 and W7? What is W1? Number of vectors with weight 1, number of vectors with weight 3, number of vectors with weight 5, number of vectors with weight 7. Yeah. So what is the answer? 0. Right? These are all 0. That is what Amya told. Is it clear to you now?
Yes, sir.
Yeah. So is it okay, Mehak?
Yes, sir.
Yeah. So once we have one vector, it is orthogonal means one vector is orthogonal to this. Okay. I'll again write here. So x, y, z, w. Orthogonal means what? Their product equal to 0, right? X plus y plus dot product equal to 0. Right? This when it is possible, we have even number of ones, right? So weight should be 1. Weight of this vector has to be even, right? So we cannot have weight 0, weight 1, weight 3, weight 5, weight 7. So they are 0. Okay. Now can you have, now we can have weight. Can I have all weights, all even weights now in CPER?
Yes, sir.
Yes, exactly. So goal is to now figure out that how many vectors are there of weight 2, how many vectors are there weight 2, forget about how many vectors are there weight 2, right? So how many positions are there? I have 8 positions, right? I have 8 positions. So how many vectors are there with 2 ones?
8C2.
8C2, right? So in general, so for example, instead of my binary, I will go general case, right? See, what is that question I'm asking? I am working in FQ. Okay. So how many vectors are there of weight? Um, so how many vectors are there of weight 1? Length 3. How do you answer it? Are you following the question? Weight 1. Weight 1 means what?
Only one non-zero, please.
1 non-zero. Remaining are 0, right? That is okay, clear. Very good. Now, so how many vectors are there? For example, if I take this is equal to 0, 1, 2, right? My q equal to 3, right? Then what happens, right? So what you do in that case, correct? So you take how many vectors? How many vectors will be there with weight 1? You know answer, right? What is the answer? Hmm? Hello?
3.
No, 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 no. Be careful.
Okay, so 6.
6. Yeah. Why that 6? What is that 6? How it came? Right? Because what are those? Okay. So for example, I can take 1 here and remaining 0. 2 here, remaining 0. Right? And 0, 1, 0. 0, 2, 0. 0, 0, 1. 0, 0, 2. Right? So these are all weights 1. Is it okay, Mehak?
Yes, sir.
These are all weight 1. But in general, how do you find it? Okay. So I have to choose one position. फर्स्ट दी 3 पोजीशंस में एक पोजीशन चूज करना है. पहले पोजीशन हो सकता है, सेकंड पोजीशन हो सकता है, थर्ड पोजीशन हो सकता है, राइट? सो आई हैव टू चूज वन पोजीशन. सो पोजीशन चूज कितने, हाउ मेनी चांसेस आर देयर? 3 चूज वन पोजीशंस आर देयर. बट आफ्टर चूजिंग what I can put there? I can put either 1 or 2. So in general, how many choices are there? It is FQ, not just 3. Q minus 1 choices. We done this earlier. Okay. On that day, connect is also there. Yeah. So Q minus 1 choices. So in general, so how many choices in general and length n now? How many vectors will be there? And choose one, Q minus 1, right? So 2 positions, weight 2 means and choose 2, Q minus 1 whole square. Remember this? Yeah. Okay. So but Q equal to in F2 to Q equal to 2. So 2 minus 1, that's not a problem. Yeah. Right. Any questions? So how many vectors are there of weight 1, weight 2 now in CPER? What the question I asked? I'll write again here. My C is equal to 0, 0, 0 8 times and 1, 1, 1 8 times. That means it is subset of F2 power 8. Right? I'm asking weight enumerator for CPER. So you told that 1 plus, yeah, tell me.
8 choose 2 into Z square.
8 choose 2. Yeah, 8 choose 2 into z square. Wonderful. Next,
8 choose 4 into z power 4.
very good. Next one,
8 choose 6 into z power 6.
and 8 choose, so it is z power 8, right? So what is 8 choose 2? So 8 into 7 by 1 into 2, right? Yeah. So that is 28. So 1 plus 28 z square plus, so 6 also same thing, 28 z power 6 z power 8. Now only thing I need to look at is something around 70 something will get. Yeah, try it. So I hope you understand the problem, right? If solve more problems, we will understand. Find the weight enumerator for this code, you understand. Find enumerator for code for this one. Can you tell me? Enter fq power n.
Uh,
1 plus,
1 plus z power q power n.
no, fq power n, fq power n. And choose one. How many vectors are
Z.
there? How many vectors are there of weight 1? Weight 1 is this number, right? Into z.
Oh,
Correct or not correct?
yes, sir.
Yeah. How many vectors are there of weight 2?
N choose 2
Hmm.
into
This one whole square into z square. Yeah, I hope you are clear why this number came. Okay, so I have n positions, right? So weight 2 matlab, weight 2 means I have to choose 2 places here, remaining all are 0, right? How many ways I can choose 2 positions and choose 2 ways? Once I choose these 2 positions, now how many I can put? I can repeat also, right? This I can choose q minus 1 ways, this I can choose q minus 1 ways. So q minus 1 whole square ways. That many vectors are there of weight 2 into z square. Is it okay now? Yeah. So now can you tell me the polynomial directly? Simplest form, compact form.
1 plus q minus 1 into z whole power n.
Right. Yeah. So this is the polynomial. Okay. Now these are the other questions. So I just explain you. So C1 and C2 are linear codes of same length n over fq. So G1 and G2 are generating matrix for C1, C2 respectively. Find the following, determine the following codes. So this is C1, is it can be linear code. C1 union C2. Linear code means subspaces, right? Is a union of two
Yes, sir.
subspace.
Not always.
Not always. Huh? So this need not. Okay, it is just code we can say, but it is need not a linear code. What about the C4,
It is a linear code.
C5, like that check. So this is a linear code, no problem. Intersection of two subspace is subspace. Okay, let us check this whether it is a linear code or not. So to check linear code, what is that I have to do? Right? I take two vectors x and y. So it is subspace or not, that we need to check. So whenever you want to check subspaces, you ask three questions. Okay, W is subspace of vector space V. What are the three questions we need to ask? Question 1, question 2, question 3. Right? Question 1 is non-empty or 0 belong to. Non-empty is equal to 0 belong to because subspace, so 0 vector has to be there. Okay, question number 1. Next to sum of two vectors, right? So W1 plus W2 belongs to W, right? Next alpha times W, right? Is it happening for this? Now we need to check that. So I take two vectors, right? X. First is 0 vector belong to this in C5.
Can you repeat the question?
is a zero vector belong to C5? I
Yes,
want
sir.
that it is a linear code or not. Linear
Yes,
code,
sir.
that means subspace or not. So is a zero vector belong to this? So
Yes,
this
sir.
C1, I can take C1 zero vector, C2 zero vector, then sum is also zero vector. Sum of two zero vectors is zero vector. So this is no problem, right? Please try to understand. This code is coming from, actually this is nothing but what? You already know this part. This is what? Sum of two subspaces, right? W1 and W2 are two subspaces, sum of two subspaces, subspace or not?
Yes, sir.
Yeah, that's what. Yeah, it is also a linear code, right? You can ask these questions, you can prove it. But what about C6? It is not like this way. Okay, this is different. It is called concatenation. I'm adding extra bits. Okay, so let us work out small example, right? So that it will be clear. So I have a code. So let us work out small example. Yeah. So for example, I have this code 0001, okay, and 1011. Yeah. And another code is this is my C1, this is my C2. C2 is equal to only 0, comma. This is also code, right? What is concatenation now? So concatenation means I put C1 and then C2. C1 belong to C1, C2 belong to C2. So are you able to see that what is that code? Concatenation of these two.
Yes, sir.
So can you tell me the code now?
Yes, sir.
So C is equal to, yes.
00010.
Okay, this 0 can be added to all of them, right? 0000001, 010, 011. Yeah. Now 1 is added to everyone. So 100, 101, 110, 111. Yeah. Is it a linear code? It is exactly f to
Yes,
power.
sir.
It is f to power 2. It is f to power 1. Right? It is exactly f to power 3. In this case, very luckily, we get all the vectors in f to power 3. So this is also linear code. So you understand this concatenation?
Yes, sir.
Suresh, what about you?
Yes, sir.
Yeah. So now the question is, it is a linear code or not? Okay, so is it a zero vector belong to this?
Yes, sir.
Yeah, because I'll take a C1 zero vector, C2 zero vector. So here also we have zero vector, right? Yeah. So this is not, zero vector is not a problem. Now I take two vectors, right? So I take two vectors W1 and W2, V1, V2 in C6, right? So I take V1 and V2. So V1 is look like C1 concatenate C2. V2 look like some C3 concatenate C4. Now what is V1 plus V2? Is it also coming from concatenation of concatenation of some vectors in C1 and C2?
Yes, sir.
What is that?
So C1 plus C3,
C1 plus C3 concatenated with,
C2 plus C4.
yeah, so easy to see, right? That's what I'm saying. Now, if I have this vector, is it scalar multiple is also there?
Yes, sir.
So that is coming from scalar multiple of the first two, right? So it is easy to see that it is a linear code, right? Yeah. But now, for example, I have two codes. So I have a generating matrix for this one. I have a generating matrix for this one, right? Now, what is generating matrix for C6? Can you see that? Okay, to understand it, so let us look at this guy, right? What is generating matrix for this one? C1.
Identity.
Very good. It is entire code, right? So G1 is this. What is G2?
Singleton 1.
Yeah. What is the generating matrix for my entire concatenated code C?
Again, identity.
Identity, but can it come from G1, G2 somehow?
G1 0 0 G2.
Oh, very good. G1, 0, 0, G2, right? Yes. So that is what I written. So show that. Yeah. And what is the dimension? Dimension is increasing or not? Is it K1 plus K2 or not? This example is suggesting that, but we need to prove in general. Uh, First of all, are you understand the questions, all these questions? That is okay for me. Doing later. So questions are clear or not clear? Amak, Amya, I think for you it is okay, right?
Yes, sir.
Questions you are clear with. Okay. So Suresh,
Yes, sir, it is clear.
yeah. So we need to show that C3 is linear if and only pro. So you know that subspaces is a subspace if and only one content in the other. So C4, C5, C6 are linear. You already done it. So if K4 is greater than 0, then D4 is maximum greater than or equal to maximum of D1 and D2. See, C4 is the intersection of two codes of the same length. So we need to show the distance now greater than or equal to minimum distance of D1 and D2. Yeah, like that questions are there. Yeah. And D6 distance is minimum of D1 and D2. This concatenated one. Huh? Yeah. This is the problem. Right? Yeah. Now I go to the next problem. So this is the question Mehak asked, right? So generating matrix is not unique. It need not be always in systematic form. But now how many generator matrix will be possible? So to answer that, so FQ power, so I have a code with NKD code. How many generator matrix are possible? Is the question clear?
Yes, sir.
So I gave a code to you. Now how many generator matrices you can form? That is the question. To form a generating matrix, then I need to form rows. How many rows? K rows. What is the condition? They are linearly independent. So how do you choose them? That is the question. So how do you prove it?
Use the hint.
Hmm?
Use the hint.
Ah, yeah. See, it is no already. You people know. So see, first row. How many ways I can choose first row? Yeah.
Sir, so there was some result in linear algebra
Ah,
that so if you have a rank K matrix, then we can find a submatrix K cross K submatrix with rank K
ah.
with full rank.
Yeah, but so when we are working with finite fields, no, right? It is exactly actually you are finding number of basis vectors in the vector space of dimension K.
Yes, sir.
See, you know that in R2, how many basis vectors are there? I can choose any two linearly independent vectors, right? This is standard basis. But I can choose any two vectors which are linearly independent. But how many are there? Infinite are there. Okay, because R has infinite number of elements. But when I work in finite field, so not only so I can even now find number of bases also. How many distinct bases are possible? Right? That is this question. Okay.
Yes, sir.
So so for example, simply we'll work here. For example, f2 power 2. So f2 power 2, you know. Okay. So f2 power 2 means actually entire f2 power 2 is 0, 0, 1, 0, 1, 1, and 0, 1, right? So how many bases I can construct, right? So 1, 0, 0, 1 is one basis, right? What is the next
Can
base?
do any two of the non-zero vectors, so can take
Uh,
three bases possible.
Here three bases, okay. But in general, how? Okay, now I replace this with q, q power 2, right? So that means I am looking for 2 by 2, two matrices, two vectors, right? You can think of matrices or whatever. So two vectors, right? What is the first vector I can choose? Can I choose first vector as a zero vector?
No, sir.
No. So how many possibilities are there for the
Any
first?
non-zero vector. So Q
Any
minus 1.
So q square minus 1 choices are there. Total number of vectors are q square. So
Yes.
I have to remove 0 vectors. So q square minus 1 possibilities are there. So once I choose that one, then how many choices are there next?
Can take anything that is not a not a
A
scalar
linear,
multiple of the
yeah.
first
So
vector.
scalar multiple. But how many scalars are there? Including 0 also I can take, because second row also cannot be 0 column, 0 row. So I can,
Q multiples.
0 q. So that is q square minus q I need to have, right?
Yes, sir.
So that is what this. So but q, now k is there. Dimension is k. So q power k minus q power I. So I hope you understand the problem completely, solution also. So if not, you can ask me. I'll explain further. But any otherwise, how what I can do? I explained also, but if still you have problem, I can do. Yeah. So this many generated matrices are possible. Is it okay, Suresh?
Yes, sir.
Yeah. What is that I'm telling? I am till one more time finally. So first row. So I have total. So cardinality of C equal to Q power K. I have to find a generating matrix. This is K cross N. Okay. I gave the code. You need to find the generating matrix. Then first row can be chosen Q power K minus 1, because one code word is 0 code word that I am not allowed. Once I choose this, that means I already choose one vector, right? Okay, now I already choose one vector. Now this should not be multiple of this one, right? How many possible multiples are there? Q multiples are there. So that is Q power K minus Q. Base I can choose this. Okay. Now third one, it is not multiple of these two combinations, right? So that is Q power K minus Q square. Like that it will go. Yeah. Last one, only one choice. Yeah. So can you see this one? So understand the question. Let C be a linear code, NKD code. CI is constructed from like this. Okay. So what is that I'm doing? Do you see that?
Yes, sir.
Can you see that what is that I done?
Yes, sir.
Can you tell? Yeah, please go
So
ahead.
just delete the ith coordinate.
Ith coordinate, right? So for example, look at this, right? 0, 0, 0, 0, 1, 1, 1, 0, 1, right? 1, 1, 0, right? So if I delete the last, this entire thing, right? I'll get some code, right? Like that. So you take the ith component and remove it. That is called puncturing. Okay. Then what is the dimensions now?
N minus 1.
N minus 1, because one symbol is missed, right? Yeah. So it is n minus 1. N minus 1, correct. Okay. And then what is happening?
K.
What about K?
K will remain the same.
K will remain same. Okay. So what is D? So these are the questions. Okay. This is called puncturing of the code. Is it a linear code again?
Yes, sir.
Yeah. Okay. Again, ask questions. So if the sum of two vectors again here, yeah, nothing. It is in the C, so automatically it is a linear code again, right? But is it a converse is true? Ask yourself. If I ask in the exam, can you do that? What is the question? So if I give a code, then you can puncture it. You will get a code of one dimension less, right? Not dimension, one length less. But if I give one dimension less one, then can you go to get a good? Can I get a code which length n? Linear it is possible. Linear code it is possible. Which one? How do you do it? Is the question clear?
The
Not clear.
parity thing.
Sorry.
Just take the parity code.
Parity. You can add all of them, then we'll get the n plus 1, right? Yeah. Okay, good. So you work out. So I just explain the problem. So is the question clear? 17th. Here I want to ask one more question related to question 16. One more question. That is called reduction. This is called puncturing. This is another called reduction. Okay, I check you how far you understand that. Okay, so so look at again this code. Okay, first explain with one example. Okay, so can you choose one position, first or second or third? Can you choose one? Suresh, can you give me one position? Which position you want? One first or second or third?
Second.
Second. Okay. So I took this position. So I'm only collect the code words with 0 or in that position. So can you tell me the vectors now?
Only 0 vectors, na?
In that position, only 0 is there. 0 symbol is there.
First and third 0.
First and third, yeah. Okay. So 1 0 1. Okay. So this is the code. Okay. This is a C, my C. Okay. This is equal to C. But what is that? I construct a new code. I choose one position in that all the vectors whose jth position is. So let us choose jth position. In that position, every vector jth position is 0. Right?
Yes, sir.
Yeah, that is called reduction. So then what is happening in this case? Is it again a linear code? What is the length of the code now?
3.
Length 3. In general, so if I take a code and I do like this, is the length of the code decreases? See, in
No.
the puncturing it is decreased because I removed the entire thing, and now I'm not removing. I'm only collecting some code words which is 0. Is it okay, Amya? Is it clear?
Yes.
Yeah. Is it a linear code again, Amya?
Yes, sir.
Yeah, it is a linear code. So it is exactly that. You see that in R3, okay. So can you tell me what is that? You understand this. So in R3, so I am collecting all the vectors which is 0 in the last position, right? Is it forms a subspace?
Yes, sir.
Yeah. So what is this actually? You know something? This one?
So plane, XY plane.
XY plane. So what is that actually we do? It is there is a map, right? Which map it is called?
Projection.
Projection map. Projecting to XY plane, right? Like that. It is like a projection. So this is a vector space. Then if I project into some, so then like that. So this is also reduction. This is called reduction. Okay. So like that. So my point is that see all these questions, previous questions and these questions are related to what? Look at these questions and these questions, right? What is it happening? If you have some codes, can I construct new codes from them? Yeah, that is the idea. Some are puncturing, some are reduction, some are extending, right? So I brought all of them at one place. Is it okay, Mehak?
Yes, sir.
Okay, is it reduction? Is it again a linear code? Yes, it is a linear code, so no problem. But try to find the dimension and other things. So dimensions n, there is no change. What about k? What about k?
Which question?
That question only, reduction part. That is not written here. I do not wrote that part. What is that I'm saying? I'm actually, so I'm I collected only those words in the jth position, all of them are 0. Okay. Then there is no change in the length. N is same. But what about K dimension? Okay. So work out. Is the dimension decreasing or not?
Is
Sometimes it decreases, sometimes it does not. Okay. When it does not decrease, see, for example, I have a code like this, right? Is it a linear code or not? Tell me. Huh? Is it a linear code or not? Tell me.
it is linear.
It is linear code. Now I take the last vector, right? Right. I remove these things. I'm not removing. I'm collecting the vectors whose last position is 0 everywhere. So what is the code I get now? Are you clear?
Same code.
Same code. So sometimes there is no reduction at all, right? And one more question I want to ask you, if you observe carefully, all of you listen carefully. Very simple question, my question. So it is a linear code, no problem, because sum of these two is this, right? Sum of these two is this, like that. It is a linear code. Okay. If you look at this position, right? Third position, first position, second position. How many zeros are there? How many code words are there with zeros? All of them have. Second one, second row, second position. How many zeros? How many code words with zeros are there? Hello?
2,
Two. First one,
2,
two. So can you make conjecture? If I have a binary code, I take some one particular position. In all code words, how many zeros can be there? Is my question clear? Amya, is it clear to you?
Yes, sir.
Okay, I'll repeat. Okay, so all of you listen carefully. These are very interesting combinatorial problems, right? So I have a linear code. C is a linear code, NKD code, right? NKD linear code. Okay, so then I may how many vectors will be there in C? What is the cardinality of C? Binary. Yeah, tell me how many vectors will be there in C?
2 raised to k.
2 raised k. Very good. So now if I take one code word, then code words. So there are 2 power k code words, right? 1, 2 like that. 2 power k code words. Each of the length is n, right? Okay. Now I take this column, right? Jth position. Okay. Now the symbol is either 0 or 1. Symbol is either 0 or 1, right? So how many zeros will be there? That is the question. Is the question clear, Amya?
Yes, sir.
Is it possible that it have all of them are 0?
Yes, sir.
Yes, we have example. Right? We have a linear code, right? This example 0, 0, 0 and 0, 1, 0. So 0, 0, 1, 1, 0, right? I can create wherever I want, right? That's not a problem, right? So this is a linear code in which the third position are all 0. If I want my first position 0, I can do that. I'll take here, right? So first position 0, right? Second position 0 also I can make. You know how to make it. Right? It is so all can be 0. So can you guess now? Can you conjecture something? Number of zeros in a jth position is
In between 1 to 2k.
that is general. That is general, right? That can be 0, it can be 2 power k, it can be 1, but can be improved it. because it is a linear code. That is the question. But Suresh, thank you actually. So you told, you are telling correct. It can be 1, it can be 2, up to it can be 2 power k. How many zeros will be there? So that is very simple, nice, simple answer. But it is, since it is a linear code, I can say more. What is observation? Can you have one here in these cases? These two examples. Look at here first code. So first row पे, first column पे क्या हुआ? How many zeros are there? 2 zeros. Second पे 2 zeros. Fourth पे 4 zeros. Look at here, 4 zeros in the first, 2 zeros, 2 zeros. So that is the thing, right? What do you predict? Conjecture, okay?
Even number of zeros.
Further, more improvement. I'm looking.
So 2 power, so 2 power m, where m is less than k.
First, why 2 power m? Yeah, good. Why 2 power m? You told reason. First, that is very nice observation. First, 2 power m. It is also some 2 power only. Why? That is what I asked that question. So if we collect all the vectors whose positions are 0, then what is going to happen?
That will be a subspace.
It is a subspace. So subspace dimension is 2 power something only. So first of all, that part. Is that the part is okay, Suresh, Mahek?
Yes, sir.
Yes.
That is the first observation. Good. Okay. You never get odds. Not only odd, even 2 power k only. But I want to improve further. I will not happy. So for example, so to make you much better, so now you stuck, you came up to almost nearby, but still we need to go a long way. So for example, I have 8, okay, 8 length. Okay, I took some position here, right? And the number of vectors is let us 16 vectors are there, right? So length 8, whatever, right? Okay, so now मान लो मैंने दिया है आपको only two vectors whose positions are 0, remaining all are 1. Is it possible? Okay, there's okay. Let us take 8 vectors. Okay, simple thing. 8 vectors with 4 will take, so that it will be easy for you. 1, 2, 3, 4. Huh? 1, 2, 3, 4. Like that, I have 8 vectors. Okay, clear. I have 8 vectors. Right. Now I am telling that. So you told that I take this position, some position. Okay. You told that number of zeros in this particular position is either 2 or 2, 4 or 8 or 0, right? Is it all of them can be 2 power 0 is allowed? 1, 1, right? 0, 0. Is 0 is allowed?
No, sir.
Hmm?
No.
No. All of it means all the places is 1. All the here also 1, here also 1, here also 1. Why this is not allowed?
Because if you add 2 vectors, then you will get 0 in that position.
No, you can tell much better way. This all entire C. Suresh will tell much better way.
Yes, sir. So zero vector will not be there.
Zero vector. Yeah, I know that he will tell. So zero vector is need to be there first. Zero vector already have 0. So this is ruled out. That we taken out. Okay. Total 8 vectors are there. Now I want to rule out this also. How do you rule out? There you will use your technique. Amya. For example, I have only 2 vectors. There I have zeros. Remaining all are ones. Right? Are you following?
Yes, sir.
So for example, I have 2 vectors only 0. Remaining all are 1. Right? Okay. 1 here, 1 here, 1 here, 1 here. So 6 ones are there, right? Then what happens if I add these two? If I add these two, right? There is a problem coming or not coming? So even now, can you guess now? What is your guess?
should divide K or something like that.
No. Finally, again, so I asked that question. So one conjecture you told that it is of the form 2 power k. That is wonderful because it is a subspace. Can you improve it? That is a question, right? Right. So my point is that either 2 power k or 2 power k minus 1 only. Half of them are half only. How? Okay. So what that I want to say is that yeah, that automatically answer this question also. Next question, right? Look at here. This is a different question. That is, and this one is different. Every linear code in F2, either all code words have even Hamming weight or exactly half of how the codes are even Hamming weight. This is different question than that, but this also helps to solve that. And answer to I am try to because time is up, so I'll try to combine both the answers in a, this answer also help you to answer that. This question is clear?
Yes, sir.
What is that I am saying? If you take a linear code over F2, then all code words have even Hamming weight. That is okay. So we have that, right? 0, 0, 0, 1, 0, 1, 1, 1, 0, right? 0, 1, 1. So it is a code and all are even weight. Even weight is possible. All of them are even weight possible. If not, then half of them are even weight, half of them are half of the code words of even weight. That we need to prove, right? How do you prove it? Okay, so how do you prove it? I am giving the answer now. Suppose A of them are even and B are odd even weight. Are you following?
Yes, sir.
Okay, so I want to say that. So if it is there are no odd weights, then no problem. I'm done, right? I want to show either of them, right? All of them are even weight. I'm done. If not, I want to show that even weight are half of it, half weight or half of it. So A is even weight and B is odd even weight. Now B is non-empty, I'm assuming. Now I want to show that cardinality of A equal to cardinality of B. Is it clear? Yeah. Okay. So now, how do you prove that the cardinalities are equal? Sets they cannot be equal, right? Huh? Are you following? They cannot sets equal because these are even weight, these are odd weight. How they can be equal, right? But cardinalities are equal. That is what I want to prove. How do you prove it?
And show some bijection from A to B.
Very good, wonderful. That is one way. And other way to prove is that I take even weight. These are even weight, right? These are odd weights. I take one vector from here, y. Y belong to B. What is y plus a means?
Take every vector in A and add it to
Add y, right? Then what about the weight of that vector? That becomes odd. We done this question previously.
Yes, sir. Yes, sir.
Then this question, weight of x plus y is equal to weight of x plus weight of y minus 2 times inner product, right? You done this question. So both the vectors are even. So if this is even, then both are even or both are odd. One is even, other is odd. Then weight of x plus y becomes odd. Okay. So now all vectors are in A are even and y is odd weight. So if I add them, then what about if y plus a? All vectors are
Odd.
odd. So, but this B is set of all odd vectors. B is set of all odd vectors and y plus a is odd vectors. What is the relation between y plus a and B?
Equal to B.
No, subset first. B is odd all vectors, y plus a is odd vectors coming from adding y to a, correct?
Yes, sir.
But what about the cardinality of y plus a and cardinality of a?
Equal.
They are equal, right? So because that cardinality of a is less than or equal to cardinality of B, right? Similarly, I can prove cardinality of B is less than or equal to cardinality of B. Is it clear?
Sir,
Huh? Yeah. Any questions? Nice, right? Not happy? Okay. So similarly, try this. So these ideas may help you to show that problem also. That is not written. I will write now as another question at the end, right? For this problem. Yeah. Are there any questions? Sorry. Yeah. So this is another problem. So try this. These are the total 20 questions, right? And this is very nice problem. This is called Reed-Muller codes. So very nice problem actually. I extended very systematically. So we have G1, right? So we just add like this GM and zeros and ones. So this is generative. Once we have generative matrix over 1m, then I have 1m plus 1 like this. Then find the dimensions and the various questions asked here. Yeah? Okay, try these things. I'll stop.